Hi, myself Mrs. Neha. I'm working as an assistant professor in civil engineering department at Marri Reddy Institute of Technology and Management. Now I'm going to present a video lecture on estimation and costing and project management subject, and I have taken a small topic in this subject. Let's go for an introduction. So the subject name is estimation, costing and project management, which is a civil engineering subject which we study in 7th semester. So the prerequisites of the subjects are concrete technology, RC design, design of steel structures, computer aided civil engineering drawing. So these are the main subjects. This CAD computer aided drawing is an subject as well as a lab. So where we can learn through AutoCAD software, we can use drawings, etc. everything. And next we can draw some detailings. And next concrete technology, we learn some basics of concrete, aggregate, etc. So next RC design, how we need to design a structure. And next design of steel structures. RC structure is about reinforced concrete structures, and design of steel structures is how a steel structure is designed and what are the steps involved, how it is the procedure. So these are the prerequisites of the subject. And next let's go for the course objectives of the subject. Estimation, costing and project management. So first of all, the first course objective is to understand the importance and fundamentals of estimation costing for measuring quantities of construction materials using methods involved in project work. First of all, for any project work, before going to start it, we require some estimation like time estimation, cost estimation, etc. anything. So for that, we need to learn what is the procedure for estimating the cost of a project. So from this, we can understand what is the importance of estimation and what are the fundamentals we use in estimation and cost for measuring quantities. There are n number of quantities which we use in construction of any project. So we need to learn how to measure those quantities. So we'll understand that here. And next, methods involved in project works, like which type of method we use for execution, for designing, etc. So all we can understand here. Next one is to understand the basic concept of earthwork related to roads or canals for estimating earthwork quantity using sectional area methods. So earthwork, basically for any structure, any project, for before starting the construction, we will do the earthwork. So the concept of earthwork, what is it and how we need to do it, how we need to start it, how we need to end it, so what are the steps involved in it. So earthwork related to roads, canals or any structure, we need to do estimation for that also. So same, earthwork quantity using sectional area methods. So we divide the complete area into some different sections and sectional area method, computational methods. So there are some other methods, we'll understand it here. And next, concept of bar bending schedule and rate analysis. So bar bending schedule. In this subject, we learn some bar bending schedule. So bar bending schedule is nothing but, so for any project, suppose we are constructing any structure, we need to design slab, we need to design columns, beams, etc. So which are reinforced. So in reinforced means we need to give bars, like bars are starting from 8, 10, like etc. mm. So first, if we take for slab, we use 10 mm bars. If we take columns or beams, 12 mm, like 16 mm, so etc. Depending on the structure strength. So for what purpose we use the structure, we'll design the bar size of the bars. So here bar bending schedule. Suppose if you take a beam, this is a beam. So this is a cross section. So here in this beam, here on top view there will be main bars, bottom view there will be secondary bars. So for these bars, if you provide these bars, there will be the bars will bend and then move out there. So we need to give stirrups. We need to design stirrups like this. We need to give stirrups. So we need to design some n number of stirrups for the required length of the beam. So these stirrups, example, so if we take these stirrups, we need some length of the stirrup, how much length, and at what angle we need to bend the ends of the stirrup, and what length it must be bent, either corner or middle, etc. anything. So for any beam or column, or if you take a column, so like this thing is concrete, so here number of bars will be there. So what are the bars? Here also we need to provide the stirrups. So, and next for staircase, and next longitudinal bars, secondary bars, etc., which we use for complete construction of any structure. So how many number of bars are required, what is the size, what is the shape, and what are the requirements, what are the dimensions, how much bent angle, how much bent dimension, etc. These are the parameters we consider and we calculate this. So inside, definitely for any before construction, so we need to calculate the bar bending schedule, just because to remove the wastage of the material and to reduce the expenses. So that is bar bending schedule that we learn here. And next, to gain the knowledge of structural valuation, tender documentation, and conditions of contract for obtaining required information to file a contract. So before any construction, any structure, some large structures like some commercial complexes or some villas or apartments, etc., any structure, before constructing it, some government will give a tender. So that tender we need, if we require that tender, then we need to prepare an estimate. So then that we can come to know that we have an idea about that, how much amount of cost it will take to construct a structure. So this structural valuation tender document, how we need to prepare a tender documentation, that we'll understand it here. And next, to understand the fundamentals of project execution and control, including resource management, time cost optimization. So first, when we talk about project execution, before complete while starting, we'll start we'll start with some equipment. So small, some materials, n number of materials are required to complete a project. So how we need to execute the project, from which stage to which stage, starting n number of steps will be there. So 1, 2, 3, 4, like this, so on. So from substructure to superstructure, there will be n number of methods, n number of works. So for every, how we need to execute those, first what we need to construct, first which work we need to start. So this is about, and how much time it takes, how much cost it takes, everything comes under project execution. So this is about this. So from this subject, these are the course objectives. Next, we shall go for the course outcomes. So here, the students, after learning this subject, they'll come to know they'll come to analyze something, they'll come to understand something, they'll apply some methods. That first one, choose stages involved in construction activities. So for any project, some stages, as I previously said, there will be many stages of work. Before construction, after construction, during construction, etc. Many works will be there in substructure or either superstructure, anywhere. So these, what are the activities involved? How many number of stages, how many works, this everything, the student can choose the stages. And they can estimate the quantities and cost. So they can easily learn how to estimate the cost, how to identify the items which we use in construction, etc. Next, outline the quantities of steel and concrete for preparing bar bending schedule. So as I said previously, bar bending schedule means calculating the quantities and their bend length, bend angle, length of the bar, size of the bar, shape of the bar, etc. So these all, they will be able to prepare this bar bending schedule by themselves. So that is by taking quantities of steel, concrete, etc. And next one, apply the mid-sectional area and mean sectional area methods for determining earthwork quantities. So for determining earthwork, there will be two methods. One is mid-sectional area and the one is mean sectional area. So anyone they can choose. So they'll come to know what is mid-sectional area and what is mean sectional area. So by learning these two methods, they can compute any method. Analyze the quantities of materials of various components used in construction work such as beams, slabs, columns, footings as per specifications for preparation of freight. So we are estimating for a structure. What is the cost estimation? So for estimating that, we need to know what are the items involved in it. Materials for superstructure and substructure. Example, beams, slabs, columns, footings, and the reinforcement, how much reinforcement is required, how much PCC is required, how much OPC is required, and everything. So these are the materials which we need to consider. So all these materials quantities must be given in as per standard scheduled rates. So for every year it might be changed. So then as per the current year's standard schedule rates, the costing and estimation will be done. So students can able to analyze the quantities as per the schedule rates. Next, use of contract documents, tender documents, specifications for the preparation of bill of quantities. So bidding details. Bidding is nothing but for tendering, we go for bidding. So these all contract documents, how we need to prepare contract documents, tender documents, specifications for preparation. So for preparing any estimation, we will require some specifications. For construction of any structure, there will be some specifications, some dimensions, some specifications, some rules, regulations, etc. So to follow all these, this subject will be useful. So students will come to know, will gain some knowledge on this subject by reading it. Next, we go for syllabus. So if we go for syllabus, this syllabus is organized into 5 units. So basic, from basic to tough. So first one, when we go for unit 1, there are, so when we go for general items of work of building, first thing is general items. What are the general items of work in a building? Before starting a construction, what, first mainly, what the things will involved in a building? What is a combination of a building? So that we'll learn here. Next, units. Next, working out quantities for detailed abstract estimates. How we prepare the estimates and what are the type of estimates, etc. So what are the methods we use for estimation of buildings? So this complete will come in unit 1. Unit 2, bar bending. And unit 3, rate analysis. And unit 4, contracts, type of contracts. And unit 5 is the big one, which is about construction project planning. So above we have all 4 units designed about complete the estimation. And next, when coming to the unit 5, we go to the planning management. So how we need to plan a project, how we need to complete the project, how we need to start the project. So everything, stages, how many stages are involved. Next, pre-tender planning, pre-construction planning, detailed construction planning, role of client and contractor. Contractor are the main person which they can increase the duration of the structure, or else they can decrease. So level of detail for development of plans, schedules, work breakdown structure. So everything, what is the schedule, how we'll start, with which stage we start, with which stage we complete, etc. All the parameters will come in the construction project planning. How we'll start and how, at what time we complete, what is the duration, what is the cost, etc. So this is about unit 5. Let us start from unit 1. So unit 1, let's go with general items of work in building. Next, the mainly text we can refer for this is estimation and costing, B and Datta. So this will be very nice, which we can learn much subject from this. And another one is, second one is estimation and costing, GS Birdy, Danpat Publisher. So these 2 books we can refer. And next, let's go for the introduction. Basically, for what is an estimation, what is estimation, costing, and project management. Let's start about estimation. First, before starting any civil engineering work or project, it is necessary to know its approximate cost. For example, to construct any structure, before starting it, we need to know the value of it, how much cost it takes, how much financially, how much we need to invest on it. So what are the materials required for it? So how much time it takes to complete the project, etc. So before starting any work, civil engineering work means any construction, any project work. So we need to know its approximate cost. We can just usually tell it as like some amount. So to guess it randomly, to inform to the client randomly, we need to calculate the approximate cost. Next, as an estimate can be defined as the process of calculating the quantities and cost of various items of proposed work. So first, from substructure, let's start. So from substructure and superstructure, there are many items of work are there. Many stages of work are there. So from this, in every stage, we have n number of works. So when we start from earthwork, there will be some other works. So what are those works? Which works are required and how much cost for the earthwork? So we need to dig it and we need to cover it, we need to fill it, we need to do the plinth, and next, etc. Going to the superstructure. So until the completion of the superstructure, what are the items we require there to complete the project, and what is the cost of those items for the proposed work. So that is the basic definition of an estimation. Next, estimation of a work is governed by quantity and quality aspect. So for construction, any structure, we need quantity and quality. So quantity is about how much quantity we related with specifications of materials. Who the client or the owner who is owner of a structure, they gives the required materials and required specifications. That depends on the quantity. And next, when coming to the quality, it comes from the drawing, which gives from the structural engineers. They give the drawings, elevations, designs, a floor plan, etc. Everything, architectural design, everything. From these drawings and specifications of materials given by the workmanship or ownership, so that combines a estimation. Next, the primary objective of an estimate is to enable one to know the probable cost of the work before completion of the project. Now, the importance of estimating. So let's go. Let's learn what is the importance of estimating. So we'll have learned what is estimation definition, but what is the importance of it? Why we need to make an estimation? Why we need to create an estimation of any project? So the estimation is necessary for fixing the budget for the proposed project. So it is necessary to fix the budget, how much cost is required, what is the amount of it, how much we need to invest on it, that we have to learn. I mean, we need to know to, so to fix the budget of the project, we need to require the estimate, we need to prepare an estimate, and next it is necessary to calculate the required quantities of materials and labors. So basically, we have no idea before starting any project that how much amount of quantity materials will be required, how many labors will be required, how much manpower is required, what are the quantities, what are the different types of works. So we doesn't know anything about it. We have no idea. So to gain some knowledge, to have some idea about it, what are the required quantities of materials, what are the materials actually, and what is the quantity of a material, and how much labors are required for the project. So we need to know all this. For this, estimate is required. And to draw up a work schedule. So based on these works, so if we come to know the works, stages of work which are required to prepare to construct a project, so we can from the above data, from an estimate, we can know how many works are there, so that we can prepare a work schedule, the starting time and ending time, how many number of days, duration, etc. So it is necessary to fix a completion period of the project. So if we able to know how much, let's approximate, if you take 1 year, then we can fix the completion project duration. So we can able to know the completion period, how much time it takes. It is also helpful to check the works done by the contractor during and after the execution. So basically, the main role in constructing a structure is contractors. So we give the work to the contractors, and they start their work and they complete their work. So during and after the completion of the project, so we need to see, we can check easily by preparing estimation, what are the works they have to do, what are the works they have done, and it is required for preparing tenders of the project. So if we going for any tender, for bidding any tender, so the when we can, if we prepare any estimation, so with that we can go for a tender easily. So if we are going any tender, we need to prepare an estimate so that we can know the amount of project. Next one, what is the purpose of estimating? Actually, now we have done what is the necessity and what is the purpose. So here, quantity and material, quantity of material and labor requirements we can know, to prepare the bills for the project, technical sanction of the project if it is any government, and next for invite and to arrange contract, to calculate the actual cost of the project, control the expenditure during construction. So that by preparing an estimate, we can know, we can control what, how much we need to invest. We get to know, we'll have an idea starting only, so that at that time we can control the expenditure to buy or sell any building. So for any valuation of any building or any land, we need to prepare an estimate. Next, idea about time completion of the project, and next to get any bank loan if required. So next one is data required. What is the data required to prepare an estimate? First of all, we are talking about estimation, but what is the data which we require to prepare an estimate? First one is drawings. So for before going to the site work, so basically we require drawings of the structure. What is the superstructure? What are the works in substructure? What are the plan, elevation, and sections which completely involved in the structure? So if we have these data, we can prepare estimates. Next one is specifications. So what are the specifications required? What are the specifications given by the government? What are the specifications given by the ownership, etc.? We need to consider. And the rates. What are the standard schedule rates of all the materials which we use in construction? Next, method of measurements. So what are the measurements, like bar bending schedule? What is the measurement we use? How many methods are there? Which methods we use? So etc. Everything we need to collect the data to prepare an estimate. Next one, same data required to prepare an estimate. We'll go clearly here. So when coming to drawings, the drawings must be clear. The drawings must be complete. Drawings, all dimensions must be available. If we have any data incomplete in this, like not clear drawings and not complete dimensions and not half of drawings, so if we have plan, we need to have section also. So all the drawings which are necessary to complete a structure, we need to have complete data. So then only we can prepare an estimate clearly and fastly. So if not, then we can, it takes long time, so we cannot prepare an estimate clearly. And next, specifications which are required. Those are general specifications and detailed specifications. There are two types. Let's see what are they. So first one, general specification. So general specification means something like class of work, nature, quality, just in basic terms. So okay, for foundation this, for superstructure this, for plinth area, like etc. Only the class of work will be defined in this general specification. When coming to the detailed specification, by name itself it defines that various items of work, laying down the quantities and qualities of materials, their proportions, method of preparation, execution, how we start a work. So with which work, execution. First thing is excavation. Next, what we'll do? So we'll dig it, we'll create trenches, we'll do lay footings, foundations, columns, etc. So complete thing. What are the materials required while constructing? By laying a foundation. So what, how many number of bars required, how much amount of concrete is required, their proportions, etc. Everything, these all very item to item minute detail is also described in this detailed specification. Next one, rates. So standard schedule rates are the more important one which we require to prepare an estimate area. For preparing an estimate, the unit areas of each item of work are required. Suppose if we are going for flooring, so we need to calculate what for length and breadth, and we need to calculate how much item is required. For flooring, how many items we require, what is the cost of each item, and the rates of various materials to be used in construction. There are number of materials which we use, so we need to learn about every materials rate. Cost of transportation, so there will not be available at our site, so we need to go for transporting of materials, so we can we'll transport from one place to another place, so the cost of this is also included. Next, wages of labor, skilled, unskilled, carpenters, etc. This all comes under like lump sum, etc. This all comes under miscellaneous. So these everything must be considered and must be required to prepare an estimate. Next one, sequence of execution. So if we talk about execution, first we need to plan. If we planning means, before starting a construction, what are the stages involved in it, how we need to start. So same, the sequence of taking out quantities of items for preparing an estimate. So how we prepare an estimate? First one, we'll go for earthwork. Basic work is earthwork, so we'll start an estimate also earthwork. Then next one, foundation, laying a foundation. Next one, sequence of execution is also laying. So whatever the items we carry out in the execution, in that order only we'll prepare an estimate. So preparing the estimation and sequence of execution both are same. It's an art of breaking up whole work into various items of work and arranging them in order. So if we talk in complete structure, but when we separate it, differentiate it like substructure and superstructure. So in substructure, there will be a number of various works. In going to superstructure, a number of various. So the complete whole structure is divided into some parts, various parts, to define the order of their execution. Next, the sequence of order. Let's see. Clearing the site. First one is we need to clear the site, and excavation, PCC in foundation and plinth, RCC in footings, beams, columns. Next, brickwork in superstructure, plumbing, electrification. These are also most important things. And next, plastering and painting, etc. Next, now we are coming to our concept that general items of work in a building. So what are the general items of work in a building? For constructing any structure, there must be some items. What is a combination of a building? What are the combination of items which we use in a building? Let's see. First one is earthwork, concrete in foundation, soling, damp-proof coats, masonry, lintels, RCC works, flooring and roofing, plastering and pointing, cornice, pillars and columns, doors and windows, painting. So if we draw here, let's think, this is the ground level. So if take, so below this is the substructure. Above this will be the superstructure. So this is substructure. This is superstructure. So here substructure, this is ground level. Here this will be the plinth area, and here this will be the PCC bed. This will be the foundation, like footings, which we'll able to design here. Footings like mats, RCC footing, and next one coming here. This will be the plinth area, and next DPC, damp proof course, and next here will be the doors above ground level, and here it will be windows, and next slab, and next first floor, second floor, etc. All like columns, beams, etc. So this is a complete structure. So in this structure, these are the general items of work we need. First one is earthwork. Before constructing, before laying the PCC bed, we need to do here earthwork. These are the items. Let's see one by one. So first one, if we go for earthwork, it is in excavation and filling, usually taken out separately under different items. So if you go for groundwork, we're preparing an estimation. First, let's go for earthwork. In earthwork, what are the items we need to describe there? So first one, earthwork in excavation, what we need to do? Earthwork in filling. These two are the separate items which we consider while preparing an estimation. So how many quantities and what is the quantity and how many items we use in excavation and filling. Next, trenches. We need to dig the trenches, and we need to dig about exact width and length which we require for a construction of any structure based on the foundation. And next, the vertical like height or depth, this varies based on the structure specifications. So earthwork in excavation foundation is calculated by length into breadth into depth. So L into B into H. So this is the thing where we calculate for a foundation. So if we see in this figure, here we need to lay a foundation. So PCC, this is a PCC bed, and we need to lay a mat there, and next RCC mat, and then foundation, concrete, and then footings. So here first this we call as height, this is length, this is breadth. So some parameters. So L into B into H, which gives the area of the foundation or excavation or else trench. Next, we need to lay concrete in foundation. As completed the excavation, we need to lay concrete in the foundation. The concrete is taken out in cubic meter. So again, how we require the trench, how we have dig the trench. So L into B into H, same length into breadth into thickness. We require the concrete. It is the units are cubic meter. So the thickness varies from 20 to 45 centimeters. So it differs on the depth. And the foundation of concrete is given by weak cement concrete. Weak cement concrete is nothing but Portland cement concrete. So PCC. A PCC is laid first on the structure, on the ground, below the ground, like in substructure. So after that, mat or raft foundation. Any foundation based on that will provide a mat, RCC mat. So that proportion, we need to define it. Either it may be 1:4:8 or 1:5:8. We need to define it, and we need to prepare an estimate. Next, see, this is the foundation. These are the steel bars which we used. This is the concrete in foundation. These all are the foundations. Next, soiling in foundation. So soiling is nothing but after excavating, after preparing a trench, if the soil is soft or bad or loose, anything. So then what we'll do, one layer of dry brick or stone soiling is applied below the foundation concrete. So before laying the foundation, we need to prepare this one layer of dry brick. So that what happens, it gives some strength to the soil. So that this soiling layer is computed in square meters. Only length into breadth, no thickness. So it is computed in square meters. Next one, when we come to damp proof course. This damp proof course is generally applied at basement levels, which restricts the movement of moisture through walls and floors. So after the ground floor, we'll lay some damp proof course. Why? Because to remove to restrict the movement of moisture. So what happens if moisture content comes into the structure, some segregation or bleeding, some etc. parameters will occur. So to restrict all this, we need damp proof course, and it is in mixture of concrete mixed designs of 1:1.5:3 or 2 centimeter thick or 1:2 mixed ratio. So with standard water mixed and provided plinth level. And next, this quantity of damp proof course is computed in square meter. Only length into breadth, no thickness. This is the damp proof course. Only this length into breadth and no thickness. So this is the damp proof course. Next one, go for masonry. It is foundation and plinth masonry is taken under one item, and masonry and superstructure is taken under separate item. So masonry, we consider it as a one item. In under superstructure, we consider walls, etc. So for anything, it is taken as only one item, brick masonry. And for every store, we need to divide it into separate layers of masonry. We need to figure it out in different layers of masonry. Brick floor, brick masonry for first floor, for second floor, for third floor, any requirement. So the quantities are measured in computed in cubic meter, length, breadth, and height. So this is the brick masonry length, and here breadth, and next this is the height. So L, B, H, everything. So for brick masonry, we need to calculate in cubic meter. Next, concrete in superstructure. So this is the ground floor, ground level. Above it is completed, it is treated as superstructure. So this, the concrete, this is slab, this is column, basement, etc. This all comes under superstructure. Next, reinforced brickwork. So for any walls or anything, for lintels, anything, we'll create a brick masonry. In the brick masonry, we require reinforced brickwork because to provide strength to it, so we'll provide some bars, small bars of a least size, so that it provides the strength to it. So this is about reinforced brickwork. Next, flooring and roofing. So after completing of any structure, after construction, completing of rooms, etc., anything, dividing the partition of the rooms, then we go for flooring. And again, after completion of slab, we need to go for roofing. So that what we use base lime concrete for floor finishing, and stone or marble or tile, etc., whichever we use for flooring. This quantity of flooring is measured in square meters. Only length into breadth we will apply for tiles, and for roofing also length into breadth. The roofing will not be in thickness. Next, plastering. Plastering is the last step which in a room which we use covering through rough walls. So to cover the rough walls, we lay concrete, and there must be uneven surfaces for roof and uneven walls. So to close it, to make it even walls and surfaces in construction of houses, we use plastering. And for any structure called mortar, which is a mixture of cement and sand, we mix them cement and sand with some proportion of water, and we use it for any uneven surfaces of the structure with required quantity of water. Next, this is the image of the plastering here. After constructing the wall, this is the plastering image which we show here. So here this is the wall, and this is the cement and sand mortar which we use for plastering. And this is the cornice, last step. Cornice is nothing but the design which we do in architectural wise. So from inside any room or any structure, architectural design is also most important. So that way, like designing here, the upper layer is nothing but it is also cornice. Next, the standard units which we do for the construction of items, there are number of items, number of stages of work. So for every stage of work, we require some units. So for earthwork, PCC for foundation, RCC, brickwork, stone masonry, woodwork for frames, doors and windows, everything, these all are computed in L into B into H. So which gives meter cube or cubic meter. Next, another unit. For doors, windows, cement concrete drill work, brick wall, DPC, plastering, painting, flooring. For all these, we require only length into breadth. So, which is given as meter square meter. Next, these are the references which I have referred and which you also can refer this. Thank you.